So, hello everyone. I've already been introduced, so this is more for posterity in the recording than anything else. So let's get started, shall we? Now, software transactions. It's quite important that we can do this, and people realized this fairly early on in the dawn of new computing. So the early 1960s, when you first came across these things called transaction processing systems. And it was basically about ensuring you had data integrity, that when you did some work, you knew that all of the data that you got left with at the end was consistent. It had quite literally special operating systems. This wasn't just some software that you ran, this was a whole operating system that was your transaction manager. And it's usually the case that the early ones were doing batch jobs, so it wasn't real-time processing. You would collect a load of data input and then there would be a big batch processing job overnight. So not like the transactions we think of today. Because the modern ones, we're really thinking about a real-time update. When people talk about doing a transaction or doing work in a transaction, they're kind of expecting to see the result of that work in real-time or near real-time, meaning within a few seconds you expect an answer. And this is actually why we got the concept of ACID. So ACID didn't really exist until people were thinking of having lots of potentially concurrent, isolated transactions. So a lot of people I talk to about transactions, they say, oh, but you know, what's all this about? We don't use relational databases anymore because NoSQL is the way to go. And there are absolutely use cases where you do not want a relational database. There was a while in the industry where the answer to any problem was use a database, and that was bad. But it is also the case that there are a lot of reasons that you do want to have a relational database. So we can't just write it off as technology that doesn't matter anymore. So way back when, it was all imperative. In order to make a transaction happen, you said, transaction start now, transaction do this thing, transaction do that thing. Starting, stopping, invalidation, all absolutely manual in your code. And this happened for a long time, and people found that they had to be really careful. There was the whole setup of, oh, make sure you only ever have one place that your code can return from, because otherwise you might miss stopping your transaction. Make sure that you've always got the right try-catch around everything, because you might miss the failure and then your transaction won't be transactional. And this is messy, and it's easy to make mistakes. And that's why we came up with declarative transactions. It was because previous attempts were messy and they had mistakes. And you just use metadata to define the transaction boundary. You don't litter your code with it. You're freed from all the boilerplate and hopefully the mistakes. So just some examples. Does anyone remember EJB1? Anyone have to use EJB1? So we remember it as actually being a little bit worse than it was, I think. So there were a lot of things that were simpler in EJB than they had been before. Fine, they maybe didn't get it quite right and it got better, but you know, it was a big step forward from what we'd been doing previously. You then have the Spring Framework, which came along and said use AOP everywhere, and that gave you another way to control transactions. You know, they later added annotation support for saying just mark it at transactional. And EJB3 basically stole all of that and said, oh yeah, but now you can do it in the standard, and CDI has gone even further with doing that. So that's kind of where we are with up-to-date Java now. And I'm going to say some stuff which, so a lot of people think that this is a pretty unpopular view, but it's to say that it's not necessarily that we've reached the peak. We haven't necessarily fixed everything yet. Because, well, quite frankly, how could it get any easier than that? It's a very simple model, and it's easy to think, yep, that's it, we're done. But what we've done is we've taken what was previously horrible complexity that was obvious in your code, and we've hidden it behind this annotation. But we haven't actually made the complexity go away. We've just pushed it under the carpet. So I agree, it is definitely better that we're not having to manually drive transaction managers and say, yeah, do this stage of your life cycle now. But we don't actually always know who is driving and whether the right person is behind the wheel. You know, how many beers did that Spring developer have? So just a little bit about what is actually happening under the covers, because one annotation, what's it actually doing? Well, somehow you have to start this transaction, and that means that there has to be some container code somewhere that's doing that. Just the annotation isn't magic. It hasn't suddenly made stuff happen without any input from anyone. No, there is real container code that has to run. And so this is usually done as an intercepting aspect. So you're running before and after every method call, and you can run basically in one of two ways. You either weave bytecode instructions in, so you actually physically change the class file as it's being loaded, or by redefining it after it's been loaded, but your code is no longer the code you wrote. It's the code you wrote plus some extra stuff. Or you create a delegating proxy, and then the proxy does some extra stuff and then calls your code. So in that case, your class is still your class, it's just when people talk to you, there's someone else who's listening in. There are different advantages and drawbacks to doing both of these things. So proxying is really, really good, particularly if you've got interfaces. If you've got interfaces, proxying is really easy, and it works really well. What it doesn't handle well are final classes, final methods, and you can't do anything about private methods. You can't proxy those. So that gives you a little bit of a headache if you want to start doing things in those methods, because the answer is simply you can't. You also can't cast to an instance type. So you've got the set of interfaces you proxy, that's all you've got. You don't have the real implementation type. So if you're doing stuff inside your own code, and you know it's really this type, the proxy maybe isn't going to help you so much. Oh, and also object identity can get a bit fun. So people talk about having to do all of this stuff to make sure equals still works, but you'll end up in a situation where you've got an object which kind of is the same object, but it's no longer equal. And that, again, can cause some problems. Things like identity hash maps don't always work quite how you want them to. So weaving doesn't have these problems, but it either needs you to have some kind of pre-deployment step to do the code changes, or you need a special class loader that's going to do the changes. It really messes up Java debug. If you've ever been in woven code and tried to debug step through, it's when you get to the first line of the method and you click next, and you stay on the first line of the method, and you click next, and you stay on the first line of the method. And it's like, okay, this is really, how do I make this stop? The other problem is it provides inconsistent behavior when you compare it to proxying. And we'll come back to that. So the other thing that needs to happen is, as well as this intercepting code that's going to do the life cycle, we need to actually do something else. We need to enlist resources into our transaction. It's not enough to start a transaction. People actually have to participate in it. If you can start all the transactions you want, unless you enlist, it's not going to happen. So, and this isn't just your database connection. This is JMS. This is whatever enterprise resource you've got needs to be enlisted in the transaction. And this is happening transparently when you do stuff. All code using the resource there's no call to enlist. But it only works if you use the correct resource. This is why when you're in an app server they say you must use JNDI to get your resources. And it's because if you don't use JNDI to get your resources, they can't guarantee you're going to get one that will enlist. Even Spring actually makes you do this. Spring is, you have to set up your database transaction manager. You have to make sure that it's going to get hooked in. It doesn't just do it by magic. Even if you put in the do it by magic bit in your XML or the do it by magic annotation, you still had to say, I want you to configure it. And then it'll do a load of defaulting, but it doesn't just happen. So proxying. I did say that there was some issues there. So proxying is normally what people do when it comes to this kind of weaving, by the way. And it's because it's less invasive. If the moment you start messing around with someone's bytecode, how do you know really that when a test fails, it's the user, or is it the code you put in, or is it proxies are a lot easier to deal with. But it doesn't give you consistent behavior. And it's the following. So what do we think happens here? We've got two methods. One of them is doing an update and requires a transaction. One of them is doing a check and then an update, and it's saying, I maybe need a transaction, but I can cope without one. That's fine. Whatever goes. So does the requirement hold that there must be a transaction in do update? Who thinks it does? So the problem we've got is you can only intercept when you call the proxy. And if we look back here, there's a method call here where we call to it, and we're not calling the proxy. There's an implied this dot. It's not called. We don't call that proxy. Do update does not always run in a transaction. And this causes real crap to happen. I mean, like really bad stuff happens because of this. You get people who have their really detailed transaction model and everything is great, and then you run it through and you have some test cases that you put them through where you inject failures and you just get inconsistent mess. And they get really shocked because there's nothing that tells you that this is not happening. It's all because it's all behind the scenes, and it's just about, oh yeah, I'll enlist if there's a transaction. Yeah, sorry, no help. Weaving will make sure that the boundary is in place, because if you weave it, it's in your method. It's before the first line of your method. So it will always work. But your application shouldn't have to care about whether the implementation is using weaving or proxying, and have to know that and do different things as a result. That's just, that's cloud cuckoo land. So we've then got something else that's important, which is transactions. We talk about atomic commits and getting everything together, but we also need the ability to roll back, because actually when things go wrong, part of being in a transaction is saying, okay, make sure none of it goes in. Most obvious reason is if your method throws an exception, you would probably want that to not commit your data. Something's gone wrong. So Java decided to do something a bit odd. Unchecked exceptions will trigger rollback. Checked exceptions do not trigger rollback. Why? The rationale was that if you've got a checked exception, it's declared on your method signature. It's part of your API. Well, I'm sorry, that's a horrible thing to do. Who uses exceptions for flow control? Anyone who does that needs to go and read a book on API design and then rethink their lives. This is a horrible thing to do. It's just, And then we come across this little nugget, which is the one that really just proves to me how bad this is. SQL exception is a checked exception. If your code throws an SQL exception, your transaction does not roll back. If you've got an SQL exception coming out, the chances are it's because something has gone wrong in some database somewhere. Do you really not want that to roll back? So what can we do? Well, declarative transactions have helped, but it's not always great. The code is definitely simpler, but correctness is important when it comes to transactions. It's not just about having simple code, it's about having code that does the right thing. As I said earlier, we had visible complexity, which was bad. We now have invisible complexity, which means that it's easy to make mistakes and not know you've made them. In a a modular system, we need to do better than that. We need to be able to make this work properly. We need to be able to express a dependency on the feature we need. We need to be able to say, I want a data source that I know is going to enlist. Not, I have to use JNDI and hope someone set it up properly. Or I have to get injected with something from my Spring context and hope someone set it up properly. So we need these consistent behavioral contracts. We also need to be able to cope when there isn't a central container. In a modular runtime, there isn't some great benevolent container that is going to say, oh, I've got everything ready for you, now go. It's a dynamic system, it's a modular system. We need to be able to plug in new pieces. Also, let's fix the transaction behavior, because that stuff is crazy. And this is why we have OSGi Transaction Control. It has two main goals. The first is to make simple but explicit management of transactions, and also to provide modular support for resources with managed life cycles. So to make this stuff easy to plug in, new resource types, easy to use resources that have just been added to the system without you having to hope. So what does this actually mean? It means you tell transaction control, make this transaction scope happen now. And you also tell your resources, this is the transaction control you need to use when I'm talking to you. And then everything else can be handled for you. You've been really explicit about what you want. How then matters slightly less. It's exactly the same functional concepts we're used to from things like the Streams API. You tell it that you want to filter, or that you want to map, or that you want to iterate. You don't tell it how to do that, but you say, I want to do this. And because you've been explicit, they know what you want and they can actually do it. So it's a functional API. You pass your business logic in basically as a function or a lambda to run, and then all of that stuff is going to run within a scope. A scope can be transactional, or a scope can be non-transactional. Transaction control gives you 4 reasonably well-known options. So we have required, which is make sure that there is one, start one if there isn't one already. Requires new, which is always start me a new transaction. Supports, which is make sure that there's a scope, but it doesn't need to be transactional. Or not supported, which is make sure there's a scope and make sure there is no transaction associated with it. I want to do some work outside the tran right now. So from this, it should be obvious that a scope is more than just a transaction, because otherwise there'd be no need for a non-transactional scope. It gives you some context for your work, so you can store some state there if you choose. It gives you a place to register completion callbacks. You know when the scope has finished. And it also gives you a boundary for accessing resources. It means that you can actually access your resources and not worry about leaks anymore, because you've got a defining scope for when you're using this thing, and it's only retrieved lazily, so there's no worry about, oh, I'm using all of this stuff that I don't need yet. But it can also be kept available for you and then automatically released at the end of the scope. And that's really useful, because you've got all of these things that talk about, oh, how do I make sure that I don't have to write all this try finally stuff? How do I make sure I don't have to close? There is nothing to close here, because you've got an associated piece of work, and at the end of it, all the resources can be cleared up and put back in a pool, or closed, or whatever. So scopes end the moment that your function that you've given to it has returned. That's the end of your scope. And resource cleanup happens whatever, and the value returned is the thing that will be coming out of your scope. So pretty simple. You do your work, you return a value, that's your result. You also have some additional rules if there's a transaction going on. So if you mark the scope for rollback, which you can do, you can say at this point, just make sure it will never commit, and then it will roll back. If you exit with an exception, it will roll back. If you exit with a normal return value, the transaction will commit. Behavior you would expect. You can have specific exception types that you say don't cause rollback. And that's because there are still people out there who put exceptions in their API and say, you know what, this exception does not mean rollback. I don't like it, but it's a requirement that you can't ignore. The main thing is, don't do it by default. If you have exceptions that don't trigger rollback by default, then stuff goes horribly wrong. So transaction control, you can just use it to create transactions and not use it with scope resources, but it really you should be using them together. And the scope resource is basically created from a resource provider. So there's a resource provider method, you give it a transaction control, and it will give you a resource. A more specialized interface is usually used, so it's not just returning object to you, because type safety is a good thing. So for example, there in the spec, which is in the R7 draft, you'll see that there is a JDBC connection provider, which will give you an SQL connection. There's also a JPA entity manager provider to get an entity manager. And the returned object is a thread-safe proxy. So you can just use it whenever you want to use it and not worry about, oh, do I need to get it now? Do I need to close it now? You just use it. So if we put all that together, you end up with something that looks a bit like this. So we inject the services that we need. In this case, it's the transaction control and entity manager provider. We create the scope resource. In the future release of DS, you'll be able to make this a bit neater because you'll be able to use constructor injection and then actually just store the entity manager away in a final field. And then when we get to it, you can actually just use this resource in the scope. And it will be cleaned up for you. You don't need to worry about anything else. And in this case, we're not really bothered about what we return. So we're just doing a persist on this object inside a transaction. That's it. Yes? Sorry?
Question. Why don't you also allow to simply inject a thread-safe entity manager?
So if you do that, you've lost the ability to say, I want enlistment on this resource with this transaction control. If you inject the resource directly, we're back to the magic container land where my resources need to be special in some way that I can't define. In this case, what you've got is you've got a type-safe way of saying, I need something that is enlisted.
Yes, sure, but you could also say, I want an entity manager that is provided by a named transaction control instance.
But then what you're doing is you're starting to put additional information around interfaces that already exist and are already used, and you're asking for people to get magic. And I'm saying we need to rely a bit less on the invisible magic and a bit more on the actually doing what it should because I know I've told it to do it.
So to make it more explicit.
Yeah. So, some advanced features to talk about quickly. You've got programmatic APIs for commit, rollback on most things, so JMS connections, SQL connections. So these are typically called resource local transactions. If you use multiple resources, then obviously you need more than that, and you've got the XA protocol to do this. And transaction control, you can either use an implementation that does resource local transactions, so it doesn't provide you with two-phase commit, but it does provide you with use for when you're just using a single resource. But you can also guarantee that you get XA support by looking for one that's XA enabled if you choose. But the API is the same whichever you use, so you're not having to worry about whether this is XA or this is not XA. That can be left down to the deployer to say, you know what, we need two-phase commit in this particular scenario. We also have connection pooling. Now, connection pooling can be challenging. I know a lot of people struggle with getting connection pooling to work properly in OSGi, and there have been lots of different ways to try and solve that particular problem. But the typical problem you run into is when the pool implementation tries to load your driver, because it tries to do it directly and it doesn't have the right imports. And the other options you've got can end up with coupling your client to a particular pooling implementation, which again isn't really what you want. And the resource provider gives us a good place to do that here because we've actually got built-in support for connection pooling in this object. Because we've already said, I want something that is going to enlist in the transaction and going to be pooled. In the configuration, we provide for it. There's a standard factory service that lets you configure all the pool information, or you can just use config admin to do it, which is what I would normally recommend. We also have no rollback for, so I did say that we needed to support people who were doing these things. So you can have types that explicitly trigger or do not trigger rollback. And you just do it when you're defining the transaction scope. You say, in this particular case, I don't want to roll back if I get a socket exception or a remote exception, but I actually do want to roll back if I get a connect exception. So you can do it. Be careful. Oh, that's all I'm saying. Be careful. Scope nesting. So because we've got this scope concept, it's actually very easy to nest scopes. So you can do a quick status update partway through a batch, so you can actually make sure that there is a new transaction or that you do something outside a transaction really easily, and much more easily than you can with other models. You know, if you want to query for sequence numbers from a sequence in your database, you typically want to do that outside of the current transaction because otherwise you're going to end up clashing with row updates on tables between different things. And each scope actually isolates you with separate instances. So you've got separate contexts, separate lifecycle callbacks. So you've got really good isolation there if you want to do nesting. A little bit of introspection, so you can query what the current scope is, what type of scope is it. There we go. So I'm just going to go ahead now, and you've all been patient listening to me, so I'm going to show you some code. Simple REST microservice. For those of you who saw what Neil was doing yesterday, we'll use JAX-RS whiteboard for request mapping, we'll use JPA to persist, and we've got a simple UI running in the browser. So, this will look pretty familiar from the example that I showed you earlier. So in this case, we're getting hold of transaction control, and we want something that provides the entity manager for this persistence unit. And we're just getting hold of it, and we're going to use it. Now, this is fairly standard JAX-RS. You can see we've got the ability to get all the messages or a particular message, delete and add. So it's really simple CRUD microservice. So we get that running. And so here we are. We've got simple UI, and we can just say things like and then we can show the messages, and you can see here we're just querying that from the database using using JPA. All very simple, very lightweight, really clear what's happening in the code. We have delete as well. It's not rocket science. It's just about being explicit about what we want to do. And all of that is coming from basically just this little bit of code. I think it's pretty cool. I hope you do too. So what I need to do now is just a little bit of housekeeping to say we're all here. It's good to get feedback because it lets us know what we did well, what we did less well, and how we can do better next time. So if you could log in and let us know, that would be really great. And just to say, the transaction control service is actually available in Apache Aries right now. It supports JDBC, it supports JPA, it has connection pooling, it supports recovery, which is also in the spec, and I've not had time to talk about today. But it's there, feel free to use it. And if you've got any questions, now would be the time.
How do you cope with custom rollback code? So in case something went wrong and I have to start manually because it's not simply a database will stop or whatever, a database rollback?
So if you've got an XA resource, then you would put the XA resource in. If you've got a local resource, then you implement a simple callback interface to say what you should do on rollback from the resource perspective. If you're talking about your application code, you can register a post-commit hook to basically get a callback which will tell you whether the transaction committed or rolled back, and you can then do what you want with that information.
Okay.
No question?
We are currently using the OSGi implementation based on blueprint and persistent XML files.
Yep.
So I was wondering what is needed to shift to this new approach.
So,
Just replacing the blueprint with the declarative services and that's it?
no, so you don't have to use declarative services. I've used it in my example because declarative services is pretty easy to show up on the page. They're just services, so any container will help. You'll inject the services and you can use them. And the example I was showing actually is using Aries JPA to process the persistence XML. So it's using standard JPA service. It's just provided a resource wrapper around it, so you can do the transaction management there. So you can continue to use Blueprint if you want. You can use declarative services, and you're still using the Aries JPA container.
And that means that no changes are required in implementation, like OpenJPA or whatever.
No.
That remains untouched.
Yeah, there are tests showing it works with Eclipse Link, it works with OpenJPA, and it works with Hibernate. And if people would like to add tests for another platform, that's great. Go ahead.
Would it be possible to have a mixed system with partly RSJPA with Blueprint and the annotations and partly control and participate in the same scope, the transaction?
So in order for that to work, you would need to provide an implementation of the transaction control service that delegated to an external transaction manager. But you could make that work. It would be a particular implementation of the transaction control service. But yes.
Any more questions? There's time for one more.
Yep.
So the providers essentially return proxies which know about the scope in which they will be working. Correct?
Yeah.
Did you think about adding adaptive methods? For example, the JDBC provider was an open mode like a data source, so it can adapt it to the data source, because it's not hard to write, but many people will do it. I think
So the important thing that we were aiming for was to make sure that you had type safety both in the type of resource, but also type safety in the service registry, where you're getting an object that you know is going to do what you need. So you absolutely could have a resource provider implementation that gives you a data source, and then the connections that you use from that. But you are going to start to change the behavior of what it means with the data source, because repeated calls to get connection aren't going to necessarily get you separate connections, because that would be violating what the resource provider is supposed to be doing. It's actually very easy, though, to wrapper the connection object in a single connection data source. And so that's a utility class that's available from Spring. It's about 15-20 lines of code if you want to write your own. And if someone needs a data source, then you can wrap that connection object in the data source and they can just use it.
Okay, well, thank you very much, Tim.